So my research interest is extragalactic astronomy, and I mostly work on the nearby galaxies with the focus of studying the morphology of these galaxies, how they have evolved, how they have formed, what are their stellar content, and I'm basically interested in one morphological class which is known as the lenticular galaxies. So in this lenticular galaxies you see basically a lens shaped which comes from the disk, which is basically very smooth featureless galaxies. And when these galaxies were first discovered, the Hubble placed them into intermediate between the ellipticals and spirals, because he doesn't find at that time these galaxies were interesting. But with the advance of the telescopes like Hubble Space Telescopes or SALT, these galaxies started to show a lot of interesting features. So now when we dig deeper to these images of these galaxies, you see a lot of substructures. For example, these galaxies consist of a bar, rings, dusts. Their disks are not very smooth, but you can see that the very faint impression of the spiral structures. So with the instrument that we have on the SALT, it offers us a variety of mode to actually study these galaxies individually or as a sample in a various details, to find out their kinematics, their dynamics, what sort of a stellar or a gas content they have. So we use the various modes of the SALT, for example the long slit or a multi slit or a Fabry-Perot, to study these galaxies into detail as an individual object or as a sample. One example of this is NGC 2328, where we have discovered, based on the SALT long slit spectroscopy, a nuclear structure. So when we looked at the long slit spectra of this galaxy, we actually noticed a lot of emission lines, and we were surprised, because when you look at the image of this galaxy, it's fairly very smooth galaxy, you don't notice anything at all. But then when we actually noticed these various emission lines, we actually looked at the various archives, and we actually did the Hubble Space Archive, and we found that there is a internal structure or a nuclear structure which actually goes up to 100 parsec of the nucleus of the galaxy, and this structure is basically consists of a very star forming region which is now known as the superstar clusters, and these are fairly very young star clusters, and or stars consist of very young stars, and SALT help us to discover that these features. So now with this kind of observations, we actually now know that the lenticular galaxies, they might have these superstar clusters or various star forming nuclear regions as well.